Good afternoon. Thank you all for coming today. My name is Joe Spiezio. I'm a solutions architect with Amazon here in Northern Virginia. I work in the civilian government nonprofit sector. I'm joined by Haider Witwit, who's in the back right now, will be my co-presenter today. Haider's also a solutions architect in our team. And we're going to be talking today about disaster recovery, particularly in a hybrid environment. I know a lot of you all have such environments. You've got your on-premise, your data center-based environments, and you're thinking about using the cloud for disaster recovery. And we're going to talk a little bit about some ways that you can do that today. So we're going to go over a few things. We're going to cover some terminology just to get everyone on the same page. We're going to talk about some ways AWS can help with recovery. We're going to look at some ascending levels of DR, some different approaches you can take in your deployment of DR. And we're going to look at some specific scenarios. We're then going to break into a demo, and Haider's going to lead this. We've actually got a live demo. We're going to work without a net today and hope everything goes smoothly. I think it will. I think you'll like what we see. And at the end, if we have some time, we'll do some Q&A. So a little bit of terminology. Some things you've seen before, just in case everybody hasn't, we'll go over them. But the term business continuity gets thrown around a lot. Business continuity refers to the continuation of business processes in the event of a disaster or an incident. Disaster recovery is a subset of that, of your systems, your technology in such circumstances. Two factors that come into this. These are areas that that companies and organizations employ in your objectives. And that's recovery point and recovery time. These are goals and criteria you put around your recovery process. Recovery point refers to the time back to which you need to restore. So in other words, how much data loss can you take, how much pain can you take in a particular application or environment before it becomes more than acceptable. So a shorter recovery point means recovering to a shorter time ago. A longer recovery point is a longer time ago, a minute ago. Recovery time to recover once you've had an issue, an incident, a disaster, a fire, whatever it is. And that is to recover, a minute to recover, a day to recover, all the way back to a continuous operation, which would be a zero recovery time, or a zero, you must have things up all the time. And that would be a high availability, continuous availability type scenario. So if you think of these two things together, it makes sort of a continuum from the time of your RPO to the end time of your potential window. The time you will have your data, you had your first bit of data loss. For highly valuable systems, for systems that are mission critical, you want this to be as small as possible. For missions that not so much, or that have static data, maybe it's not so important that you have it here. But transactions loss plus downtime is that window. And we're going to talk about for that. Disasters, there's lots of different kinds. There's natural disasters. There's weather-related things. We have fires. Where the whole, you can have loose things underneath. Everybody has this happen all the time. At Amazon, there's always, we go through hardware like crazy underneath, and we manage that. And you can have human-related issues where either malicious activity or corruption in your data, hackers and so forth. And depending how you want to address these things and where the issue is, you may, again, want to have a shorter or long recovery time. So you will have either high availability solutions or traditional backup to handle either of these, any of these kind of scenarios. So a little bit on, historically, disaster recovery has its own challenges. And if you're running in your own data center and you wanted to have a separate instance or a separate place for that before, you could either traditionally, make tapes and store them off-site, or if you really are extensive or heavily engaged with it, you would build your own data center. Very expensive, very time-consuming. You have to do testing, which sometimes works, sometimes doesn't work. It's kind of specious there, and you have to work on meeting those RPO and RTO requirements, which can be challenging. And there's an element of technical debt involved here too, with regard to, do you do it the easy way where it's going to be hard to get everything back later? And I remember, for years, whenever there was a disaster, the worst moment of the recovery is when you take that tape out and you put it in and hope it works. Sometimes it does, sometimes it doesn't. But that's, that's part of the nature of historical DR. When you use an AWS environment or any cloud environment, some things that change are that capital expenditure goes away. A lot of that front-end cost goes away because you're using the data center that we provide to pay as you go. So the upfront cost goes away to a vast extent in terms of CapEx. You still may have to put your on-premise equipment, maybe a router, maybe a connector, something to get there, but the cloud-based infrastructure is there for you. The on-demand costs for your OpEx are at pay-as-you-go, as I mentioned. You can automate your recovery. This is really a huge feature, to be able to have script-based recovery, auto-scaling, and things like that. And we'll talk about that in a few scenarios coming up. This is really not to be understated component, that you can have separate levels of DR. It's not just one tape for everything you have, one approach for everything you have. You can have different recovery, RTO and RPO, for various business lines, for various applications, and you can do that pretty seamlessly and without major acrobatics. So if we look at a topology map, and I apologize, the dots in the middle are a little faded out, but there are lines crosswalking these left to right, right to left. You see on the left the traditional terminology, and on the right the AWS analogs to these terminologies. So everything from DNS and load balancers to web and database servers, and all the way down to data centers, which in our case map over to our availability zones. If you don't know what those are our virtual data centers, which are made up of physical data centers in a region. They're all separate and run on different floodplains, different power grids, and so forth. We have an analogous structure. So when you talk about mapping out your applications in an AWS data center, an AWS region, you're really talking about something that's familiar, just may have different names. So here we go, get these guys here. When we talk about ascending levels of DR, there are multiple approaches to this. We're going to talk about four. Get away from the hotspot here. We're going to talk about four different approaches to this. The first is traditional backup and restore. This is where you make a backup copy of your environment, of your data, and you put it somewhere. Typically, in an AWS scenario, we're talking about putting this into the cloud, storing this in S3. It could be a database backup, could be file backups, whatever you want to have there. And this is typically the least expensive way to do a backup. And we store that out in the cloud, and we show here a 24-hour RPO and RTO and a low cost. The next is what we call Pilot Light. This is probably the beginning of what we start to think of as a high availability solution. And we'll talk about all these in detail in a few minutes. But Pilot Light basically replicates the data and then has a minimalist structure on the cloud side, basically that allows you to spin up your environment very, very quickly in case of a disaster. And you can then, but very cheaply, because you don't run it when you're not in a disaster state. You simply fail over to it, turn it on, and go in the cloud. Again, relatively inexpensive, a little slower or a little faster, much faster on the uptime than disaster recovery, but a little slower than the other ones we're going to talk about in just a minute in terms of RTO. Warm standby is the next one, and this is one I really want to focus on today. I'll tell you why in a minute. Warm standby is a case where you have live data flow on both sides. You have your core application running in your on-prem environment, and on the AWS side, you have basically a trickle of data coming through through a live application stack into a database that's replicated over from the on-premise to the cloud. And this can actually provide you with a very, very close to a full high availability solution. It's not scaled to full capacity, but it's fully functional. So if you have a failover, it can happen almost instantaneously, and you can continue to operate with the use of auto scaling and some other automation tools at full capacity, and hopefully your customers never miss a beat. This is the scenario we're going to show in our demo later today. So Haider's going to run that for us in a few minutes. And we've got a live one running, so we'll see. I think that will work for you just well. And the last one is multi-site. Multi-site is a full-scale duplication of your environment in the cloud with replication going both ways on the database side and fully scaled out platforms, both web front ends and application servers as appropriate. So the fastest to fail over, the most expensive of the bunch because you've got the biggest pieces running and they're running at full capacity all the time. But you start to see at the bottom, from the Pilot Light to the Warm Standby and multi-site, these are your high availability type solutions. You can actually feasibly have continuous operations in these, and you see the red line at the bottom. Business continuity beginning somewhere in that Pilot Light, depending how you do your failover and how you configure that. We'll take a look at it in just a minute. So the backup and restore, you see these are the tools. These are the AWS tools and components that you would use typically in any of these environments. And it's sort of an abstracted version of that. But basically on the left, you see that the pilot light is mostly focused on storage solutions and connectivity. So VPN and Route 53 with Route 53 being our DNS, to route into the cloud and connect you there. Putting your data into S3 with its high durability and its high availability, and Glacier for your cold storage for your long-term storage and archive. When we move into Pilot Light, we start seeing the more operational features. So EC2 is out there. So we see actual instances running in the cloud. EBS volumes. Typically you see RDS out there as well. CloudFormation is used as a deployment technique. And then Direct Connect comes into play for the first time. Direct Connect is really, really valuable in this kind of scenario, to have that very low latency, very high speed connection between your environment and the cloud. It allows you to do things like synchronous database replication, which is really kind of a great feature to have in such a failover. And then we get to warm standby. We start adding things like IAM, auto scaling, and any of these could actually be used in any of the high availability solutions until we get to multi-site, when you can use literally anything we have that matches up with what you do. So backup and restore, we talked about this a little bit already, but essentially you're connecting over to the AWS cloud. You're using either or combination of storage gateway or other appliance, or your own backup system that you've already had out there running and operational to send your backups to the AWS cloud. You can store them in S3 buckets. You can configure that any way you need to. You can set up the security that is appropriate for you to do this, and you can archive out to Glacier. This is, again, cheap. It's very reliable, and it's probably similar to what a lot of folks are doing now. So it's the least disruptive in terms of process, because things like Storage Gateway can present as an iSCSI interface. You simply plug them into the existing software and go from there. It makes it very easy to integrate this as a first step for folks just dipping their toe into cloud for disaster recovery. So you see on the right-hand side, here's a little bit some numbers on this. This is an estimate. We're talking, I think, here about 4 terabytes of storage, including half of that in Glacier, coming through 2 different channels with a VPN connection. Estimate about $200 a month for this kind of configuration. And I'm talking about some examples of this. This is for something that would not be the shortest duration recovery necessary. If you've got something that's immediate, you may want to go with a little more high availability solution, but it's really good for some that require a low-cost option that have a longer RTO and RPO. You can leverage your existing environment as well. If you've got investments in things that can do dedupe, compression, and WAN acceleration, et cetera. Some of our partners who do this include NetApp, who's a very good partner. They have a product called AltaVault, formerly known as SteelStore, which can help do this as an appliance, again, along with our Storage Gateway and several other partners that can participate with this. But when you use a partner product, frequently they can add value to what we do natively in AWS. So for instance, they can add compression, they can add encryption, they can do deduplication, they can really drive down the cost of that storage over time. So I encourage you to look at those solutions as well when you're considering how to do this. So here is a quick map of the architecture of what Pilot Light looks like. And the first step of this is the hot piece, which is the database. Because data does not necessarily scale out as quickly, you want to make sure that you've got that database going. And what we do is we replicate that database over on a regular basis, either synchronously or asynchronously, from the on-premise on the left over to the cloud, which is on the right. So we have a database server there. It's up to date all the time. We add to that a load balance configuration with web servers and application servers, which in this case are not live. These are either stopped or they are in the form of a CloudFormation script that you would launch upon failure. So a CloudFormation script, a typical LAMP stack script that you run from our console will take about 20 minutes to load for a 2-tier architecture. So it's going to take a little while for the CloudFormation to load. If you've got them off, it takes about the time to boot up, so it takes a few minutes to come up. But you can also, so as soon as you fail over, you can launch that. Route 53 will allow you to do a failover configuration, so it can automatically fail over to this. You can even use a Lambda function to trigger the action to kick off the script or to launch the instances. So you can automate this pretty well, and you can actually get, we talked down at the bottom or the previous slide about a 4-hour recovery time, or a 12-hour recovery time. You can get this down much faster than that by using some automation and some scripting to do that, and hopefully never have to touch it. Just have it fail over, send you a page at 3 in the morning that says, hey, your system was down, and now it's back up, which is much better than the alternative. Some estimates on price. This is actually a very, very frugal alternative for disaster recovery. It gives you that full capability of failing over. Even if you have a smoking hole scenario on the left side, you can actually be back up and running in a pretty short time on the right side. If you add auto scaling into this, you can scale back out and be up to full production in pretty short order. And on an ongoing basis, because the servers don't run, they're not operational, you're not billed for them, and so the cost there is zero. So the cost here, in addition to what we talked about previously, is maybe another $100 a month for the database server and the storage there. If you add direct connect, it might be a little bit more in that capacity, but but the latency there will be much lower, and you have a pretty good impact. We find that to be a pretty high value connectivity option if it's suitable for you. But here, estimate about $309 a month. So some details on Pilot Lite. We talked about this already, but for shorter RPO, RTO, you can get this up really running very quickly. Higher nature, and this is again one of the start of the HA options. So the next was warm standby, and this is the one we're going to show you in a little while. I said the difference here is that the servers on the right, the application stack, and assuming we're talking about the same application we talked about a minute ago or something similar, the two-tier application here with load balancing in front of the web and application tiers. Going back to that database server, we have replication coming from the on-prem side over to the cloud. We have load balanced distribution at the top, or balanced distribution from the Route 53. And typically what we do here is a weighted round robin. So we'd send most of the data over to the on-prem, and then maybe 20% or some trickle of data over to the cloud side, just to make sure it's still running and things that still work. You maintain your servers as you would in the Pilot Lite. When you drop code, you update these, and you keep things going as you would normally, so that if you have an issue, it'll fail over and won't miss a beat, because Route 53 will automatically fail the traffic over. It will continue operating. If you include auto scaling in this, you can just scale out your web tier and pick up the full capacity in a few minutes, and hopefully your customers will never be the wiser that you had an issue. So some numbers on this one, a little more. Again, we're talking about $410 a month for a comparable size application here, again, because you're running the servers all the time, where you weren't running them before. They were cold in the Pilot Lite model. So multi-site architecture, again, the next logical extension of this. This is the difference between this and the warm standby, is that here we're talking about a fully scaled operation. So this is the fastest failover and the fastest back to full operation, because you don't have to scale it out. This is comparable to what you've historically done in terms of mapping to or scoping to your peak capacity, but at least to your full operational capacity from an AWS architecture perspective, so that if it fails over, you've got everything you need. Typically, you'd run this. You can do this here, as we talk about, in an on-prem to AWS environment. You can even run this AWS to AWS. The comparable version would be region to region, as opposed to within intra-region. But here you can fail over completely. You can do bidirectional replication, assuming your database supports that, and be fully functional in this environment. It's the most expensive, but the fastest to fail over, and the fastest to get back up to speed in terms of RTO. So here we're talking a little under $500 a month plus Direct Connect for its functionality. So again, these are for the fastest to turn over, the fastest to get back on board with RTO and RPO. For your core functions, for your core applications, these are really a great way to go, because again, they'll keep that continuity going, and again, much better to get the page that's back up than the page that it's down. So a little higher cost, and there are plenty of partners to do this. If you go out to our expo, and probably many of you are in the room today are with partners, AWS, we provide the building blocks for this. We provide the architecture and the guidance, but we have a great partner community that can help you build these things and put them into place and put hands-on with you and really get these things going. We'd love to provide guidance and work with those partners, but they have much more scale and reach than we do. So we'd love to see you engage our partners to help build some of these scenarios in your environments and really get them going. Now, that said, on our own front, Haider and I spent some time really getting this going over the past week. So we've built a warm standby environment. It looks something like this. And so we built an application on the left and one on the right. I'm not going to steal Haider's thunder. I'm going to let him go into this. But we're going to run this out. Are we ready to go, guys? Okay, we're ready. Haider's going to run this from the back because we had a little technical difficulty with screen replication in the front. But I'm going to stand up here and try not to be in the way. And I'll let Haider talk from the back.
Hey, everyone. I'm Haider Witwit. I'm a solution architect with Amazon Web Services, and today I will walk you through a demonstration for how we can use AWS services to better plan for DR and meet hard, aggressive PTO and RTO requirements. So to start with, let me tell you pretty quick how we built this demo, what ideas we had in mind. Since usually most of the companies who want to consider AWS as a DR is basically running on-prem, so we wanted to start with a basic multi-tier web app application that's running on-prem. We have a load balancer. This is a VMware environment, so we choose HA proxy to configure as a load balancer. 2 front-end servers. And the 2 front-end servers are pointing to a database. This is a Microsoft SQL database. And we, of course, have an AD server to provide the AD services for the environment. So this is the typical on-prem. The first step was to let's see how we can extend this environment to the cloud and kind of plan for how we're going to do this DR planning. We choose the region. This is AWS. This box, the external box, will represent AWS. We've chosen US East 1. US East 1 is my region. And we started with configuring a VPC. To provide the connectivity between the 2 environments, we decided to go with AWS Data Connect. This is a dedicated connection that customers and clients can provision between their on-prem environment to AWS. In our case, this is a 10 gig pipe, physical pipe. Then we started to stand up the environment on the cloud. So this is a secondary AD for the same environment. And we configure Active Directory site and services to control the replication between the 2 sites. And then there was a part of planning for the database replication. To follow best practices of Microsoft, we decided to go with Microsoft SQL Always On service and to go and configure a listener to kind of map to 2 backends or database servers. One of them is running on-prem DB1, and the second one is on the cloud. Because we have a very good connection and because the application that we developed is not really resource intensive, we decided to go with a sync replication, which means that any transactions will be written on the 2 databases before it will acknowledge to the web app. And we added on the top of that, of course, the web app tier. And we use, of course, EC2 to configure 2 front-end apps, exactly the same like we have on-prem, and use our ELB, Elastic Load Balancer, as a load balancer service that will be kind of run side by side by the HA proxy on-prem. So now at this point, we need to connect to the environment. And for that, we definitely use Route 53, our DNS service. And Route 53 here will host the external site and will do a weighted routing for the DNS resolution. This is a configurable thing, so you can put whatever you like here. We had basically 2 options. We could have done failover. In this way, 100% will go to one side that you choose, and the second one will be standby. And to trigger that, you configure health checks. And basically, we'll ping these 2 backends, load balancers, and the service can detect if one of them is not healthy, and we'll do an automatic failover in this case. Of course, you have a good set of values to change. You have time to live, health checks, and we tweak them to kind of show the demo today based on the application requirements here. And of course, they are doing health checks so that the failover is automatic. So this is the current status of the environment. We have everything running right now, and the first thing we'll try to demonstrate is to demonstrate a failover for the web app on the on-prem. Before I go through that, let me show you a web app that we developed just for this purpose, to show you how the traffic flows. And in this case, we basically have this web app, an application that sends requests every 5 seconds. And from what you can see here, that app will show you where it goes. Of course, this will go through Route 53, and Route 53 will direct that traffic either to on-prem or AWS. We added these colors so that it's easy to differentiate where the traffic goes. The orange is AWS, the white is on-prem, and the green represents a new record, and this is a temporary identification just to show you that there's a new record. There is a timestamp, and of course the delta in seconds represent the time when there is a new write. So if you keep an eye on that, you'll see 4 or 5 seconds, the application sends a new write request every 5 seconds. So the purpose of this app is to show us how the failover will work, the effect on the web app, on the web tier, and the database when we do the different failover tests. So let's switch to the environment where we can actually simulate our test. So again, what we'll try to do first is to disconnect the load balancer. So this 80% that's going through the on-prem environment will go down, or there will be an issue with that connection. What we'll try to show you is how Route 53 will react and take actions based on this change that we'll do, which is taking down the entire app tier. To simulate that, again, this is a VMware machine. So I'll switch to my VMware machine. This is an HA proxy. Go to the network setting and disconnect the card. So now I've lost my on-prem part from the application perspective. And what I should expect here, based on the TTL values and based on the health checks, how my environment will react, and specifically how Route 53 will react and direct the traffic to AWS. And as you can see here, now all my traffic is going through AWS, and there was a small delay between these two requests from 5 to 10 seconds. I believe this is the time when it detects that there is an issue, and now the app is still trying to recover. My goal is to show a consistent delta in the write request on the AWS, which is what we are showing again. So although we basically killed the entire app tier, and we show you how we did that, now by tracking that was really had a minimum effect on my application that even a basic network monitoring or application monitoring will not even detect. Of course, I can configure monitoring to generate alerts if an incident like that happen, but my Route 53 service did a very good job in failing over without really affecting on the availability of my application. The second thing that we would like to show, so of course when I disconnect my load balancer, I expect the traffic to route from 80% to 0% to the on-prem and 100% going to the cloud, which is what I saw on the application. The second thing that I would like to simulate is what will happen if of course, currently my database, my DB1 is the primary. So my primary site is still on-prem, and all of the write requests are basically being sent to DB1. So what will happen if I kill DB1? What will happen if I just unplug the DB1 server and test how good my connection is, how good my AWS in doing sync replication for all of the transactions that I'm making on every 5 seconds on my database. To show you that, I would like to go pretty quick on what setting I have from the always on service, SQL always on service. And I have an RDP session to my database on the cloud, and this is a quick view on how things look like right now. I have a cluster. I have this is the listener configuration, and basically the listener is the resource that you will configure, and this resource is a name that's pointed to an IP address, and DNS will take over of pointing that to the primary, where the primary is. And in my case right now, the primary is DB, and DB is the one on-prem. My secondary is on the cloud. They both are synced, so in case if failover happen right now, there should be no data loss. From a Windows Server failover clustering, which is the service that always on use to provide the high availability, I have a cluster of 2 machines. One of them is on-prem. The 119 is on-prem, the 219 is the one on cloud. This offline indicator does not really indicate that the network is really down. This is just the way Microsoft provide the high availability for subnet for nodes on 2 different subnets. So now that I've seen that, it's about time to actually show what will happen if I disconnect my database. So this is the VM that's doing DB1, and now if I want to maximize that and see how will that affect on my application, put them side by side, and see what will happen if my entire database get disconnected now. Keep an eye on the application. Try to see how will that survive a severe outage like that. Let's see how notice my clustering services. It's failing now. It's detecting that one of them is down. It's trying to recover. It brought the other one online. As you can see, this is online now. The cluster service is up. Keep an eye on my application. My application is currently experiencing some issues because it just lost the database. Let's take a look at, okay, here it's up. We started to see traffic going again. There was a small delay here between 5 seconds, and it's good. Oh, we have 20 seconds here as well. Imagine that a huge outage like this, killing a database, an entire database, will only cause you 15 seconds of delay on your application. Of course, on my always on service, I can see that there is an issue. Let's refresh status here, see what the issue is. The issue is I have lost DB. Remember that DB was the primary before, now DB is secondary, and DB2 is the primary. And of course, my application doesn't seem to have any issues now. And everything is going through AWS. First, I've simulated killing the entire web app and see how will that affect. That didn't really cause a lot of damages, so I decided to kill the database and see how will that affect. And that also didn't cause a lot of damages. Basically, because I have the right tools and I've configured them in the right way to really provide high business continuity for my application that's running in a kind of spanned or a hybrid deployment. Part of it is on-prem and part of it is on cloud. Now the end result is that everything is 100% running on the cloud. And once I have my stuff here, I can basically keep them there. I can fix my issue here and then try to fall back. It's up to me on how I want to take it from here. You guys have any questions? I'll be happy to answer on how we configure that, what kind of techniques, timeout values. We are happy to answer any kind of that questions.
You want to turn the other one back on, Haider?
Okay.
Put the connection back on. We got a few minutes, so we can.
So what do you want to look at?
Bring it back to health if you want. Why don't you bring the
app?
The on-prem back as secondary? We can.
Oh, so you want to bring back the
fail back.
Okay. So we have a request.
It will eventually come. It will come back. I'll tell you now, the TTL is a little longer on the on-prem side, so it might take a few minutes. But
so you want the front end or the database?
Let's do the database first. That's faster.
So let's
he wants the front end, but I want the database. So we do the database first, then we'll do the front end.
So this is the database, and now we will bring the database back by restoring back the connection.
And we'll get started while it's cooking. We'll take some questions
now
too.
that we are restoring connection, of course, that's not going to look at all at the database, at the application side, because the application is dealing with the virtual resource.
Right.
This virtual resource that is the way of how we configure SQL always on is a name, and that name is mapped to an IP address. DNS takes care of what is the primary, and it will make sure that the primary is always what DNS provides. So in this case, even if I restore my database or restore the connection to my database, that will not affect at all on my application. However, to see that, I should be able to go back to my SQL services. Oh, see, let's refresh that, make sure this is up to date. Yep, so it sees that now it came back on. However, now DB is the secondary. It's not the primary anymore.
Want to turn back on
So
the
let's
HA
turn
proxy?
back on the front end, because remember what we did is that we disconnected the HA proxy, which is my load balancer on-prem. So the time it will take to start to route traffic back based to the weighted version will depend on the TTL values of my health checks. So remember that health checks is basically a ping requests, an HTTP ping request in our case. And these are being set every 10 seconds. And I believe 2 consecutive checks need to fail before it considers the site as down. So right now, what I'm waiting for is for the Route 53. Oh, see again, we have on-prem stuff again. So Route 53 detected that the on-prem site is back up. It can route traffic, and now it's taken the normal weighted values that we have set on the application.
We're back in business.
We're back in business.
Gotta love a live demo. All right, I think we've got some time to take some questions if anybody has any. As we got in the back here, we got one.
Oh.
I'm sorry, I can't hear the question. Recovery server logs.
So let's switch back to the screen.
What kind of scenario are you talking about? Just
I'll go up front.
if they're backed up, you can recover them. We can talk about that offline, and I don't really have that in this part of the demo. Haider, do you have any
I didn't get the question, I'm sorry.
questions about recovery of server logs?
Push them to CloudWatch logs.
Oh, yeah.
So remember that things works is based on how you configure them. In our case, we are doing replication, continuous replication for the database. So if you are pushing the logs in a certain database log file or partition that is part of the replication, because on the always on, you basically choose a database, you right-click, you enable high availability for this database. Everything within the database will be part of the replication. And this is a configurable thing. You can do sync, you can do async, you can do manual failover, it's all up to you. Our job is to give you the tool to do the best practices based on the software vendor and based on the application requirements.
Yeah. And from an on-prem standpoint, you're going to run a traditional backup and DR model on your server logs. On the cloud side, we can use, again, as Bill mentioned, the CloudWatch logs to store your logs and keep them in. Either way, you can keep them out in S3 and bring them back in. But again, the best way, we think the first recourse is HA. If it doesn't go down, restore is not such a big issue.
And ScienceLogic, there are a lot of partners who are developing a lot of tools to collect logs, monitoring.
Yep.
ScienceLogic is one of them.
Full ecosystem on that. And there's another question up here. Another question? Yeah.
In this case, on-prem, the primary was on-prem.
Primary was on-prem.
Was on AWS.
That's correct.
Do you recommend to have a DR side if the primary is in AWS?
Typically, when you get a primary in AWS, what we recommend in any architecture is that you design and implement a multi-availability zone architecture. So when we think about availability zones, we're talking about physically separate data centers within a geographic metropolitan area. So they're connected with very high-speed links. So you typically have less than 5 millisecond latency between them. So definitely configure multi-AZ, which gives you a multi-data. And configure DR across your availability zone. So high availability and DR across your availability zones.
If you allow me to ask me a question here, what do you think more reliable and available? More high availability and reliability you get by running stuff on-prem or on the cloud? What do you think the chances that your stuff will fail on cloud or on-prem? Take a good look at the SLAs, take a good look at how we do things, what is the durability that we provide, what are SLAs that we guarantee, and then you make a decision on which side you think that's more likely to fail in case of things went bad.
But it goes to the answer that even in the cloud, especially in the cloud, we always recommend having redundancy in your environment. So run auto-scaling groups so that you can have self-healing applications. Always keep your auto-scaling groups with a minimum number that you need so that if it fails, it will come back up at that level. Again, use multi-availability zones so that if we lose an availability zone, if a meteor strikes Northern Virginia and takes out one of our data centers, you come back up on the other side, just like we showed here. The on-prem can just as easily be replaced with availability zone 1. The our AWS side can be just as easily replaced with availability zone 2.
In fact, we have CloudFormation templates. These are the way we kind of really simplify the process of launching an entire environment. There is a specific CF template, CloudFormation template, that you can launch this entire environment in a single click and only provide the username and passwords to log into the environment.
Right.
And it will simulate a very similar thing. Of course, there is no data connect in this case because there is no environment on-prem to connect to. Everything is going to run on AWS, but it provides everything, all of the information, and you can test it by yourself on the cloud.
There's a white paper that goes with that, and you can launch an all cloud-based system very similar to ours.
The reason it really took us a good time to build that is because there was an on-prem part.
Yeah,
So
the on-prem part's the difference.
there is not as easy as...
One more question here.
Okay.
So, if for whatever reason you wanted to do a double suspender solution,
Yep.
where you had failover across AZ and DR to another region,
Mm-hmm.
you typically run sync between the AZs and then async between one of the AZs and
Yep, right on. The latency between regions is typically is prohibitive of doing synchronous replication between
Latency
regions.
is a key factor here between choosing if I'm doing sync or async, because if you have a wrong type of connection, if you have a high latency, doing sync can affect, in fact, on the application performance.
And just speed of light, even with a high-speed connection from East Coast to West Coast, will prohibit that.
typically are you going to do async from the primary or from the secondary?
Yep. In our case, we had
I see what you're asking.
1 second latency for the connection between the two sides.
I think that's a judgment call. I think you can probably do either one and be just fine. You obviously get a little bit, it's going to be really, really minuscule difference. But either way, the front end, the Route 53 end, could be almost identical to what we have here with that global balancing. I think we're just about out of time.
We
One
have
more question
another
back
question, quick
quickly.
question, hopefully.
Yeah, I'm having trouble hearing the question, but I'm sorry, we're just out of time. Come on up and I'll answer your question.
Can we
up here.
take this question offline?
I think we'll take any questions you want offline. We'll be around for a few minutes, and we'll be out in the expo and at the reception later. So if you have
And
questions,
thanks everyone
please
for your
stop by
time
and say hi.
today.